If you want systems that don't crash during traffic spikes, don't freeze on long tasks, and don't lose data when a worker dies, you need to understand queues. They're simple, but they quietly power almost every large-scale system you use. What a queue really is. A queue in distributed systems works just like a line at a coffee shop. Requests come in, wait, and get processed in order. But in production, queues aren't code snippets. They're cloud services like Amazon SQS, RabbitMQ, or Kafka, built to handle millions of messages per second with automatic retries and fault tolerance. Some queues are FIFO, some prioritize urgent messages. But the real value is decoupling producers from consumers, buffering traffic spikes. Imagine your service gets 1,000 orders per second, but your database can only handle 300 writes per second. If you push traffic directly, you either crash the database or drop requests. With a queue in the middle, producers keep sending requests instantly. The queue absorbs the burst. Consumers process at a safe, steady 300 sec. Nothing breaks, nothing is lost. This is a classic architecture. API gateway, queue, auto-scaling workers, database. Even if traffic spikes 10x, the queue buys you time, making APIs asynchronous. Anything slow, video encoding, file processing, emails, payments, shouldn't block an API request. Instead, 1, the API accepts the request. 2, it drops a message into the queue. 3, it responds instantly. Task received. 4, background workers handle the heavy lifting. Users get a fast experience, and your servers stay responsive. This pattern is used everywhere from YouTube uploads to PDF generators. .fan out for microservices. When one event needs to trigger multiple actions, like a new user sign-up, you don't want one service calling everything. Instead, publish the event to a topic. Each downstream service has its own queue. Each one processes the event independently. Welcome emails, analytics updates, CRM entries, all handled separately without tight coupling. This is foundational to event-driven architectures used by companies like Netflix and Amazon, fault tolerance with visibility timeouts. If a worker crashes mid-task, queues don't lose the message. They temporarily hide it using a visibility timeout. If the worker never confirms success, the message becomes visible again and another worker retries it automatically. This built-in retry loop is one of the biggest reliability features queues offer. Dead letter queues, DLQs. If a message fails repeatedly, maybe it's malformed, it's moved to a dead letter queue instead of retrying forever. Engineers can inspect it, fix issues, and reprocess it manually. This isolates real problems without blocking the entire system. Queues are one of the simplest tools in distributed systems, but they solve some of the hardest problems. Traffic spikes, long-running tasks, microservice fan-out, and fault tolerance. Master them, and you unlock the foundation of modern scalable architecture. Follow for more.